I would like to kind of go over the review of the first quiz on Unit 1. So the first topic we're seeing is polynomials. So that's the first thing we kind of did is some things on polynomials. So polynomials, we're dealing with just several termed expressions. So the first one we're going to look at is what's called a trinomial. There's three terms here. So remember, to see the terms, you can kind of do the circle thing. There's the first term, there's the second term, and there's the third term. Those are our terms. So if I want to identify the quadratic term, remember, quadratic term is the second degree term, which is the x squared. The constant is the number at the end without the variable, which is the negative 15. And remember, the degree of the constant, remember the degree is the exponent of the variable, but the variable on the end was x to the 0. And remember, x to 0 is equal to 1. So really, negative 15x to the 0 is the same thing as negative 15. So the degree of the constant is going to be 0 because that's actually the degree of the variable. So we learned that the degree of the constant is always 0. Now, if I want to factor a trinomial, so if we're trying to factor this, let me give myself a little bit of room here. So if we want to factor this x squared minus 2x minus 15, if we want to factor this, since the quadratic term is x squared, we know we can just make this a binomial times a binomial. And the only way to get an x squared is x times x. So we're halfway there. So we have to just figure out what are the factors of the last term. So the factors of the last term are this negative 15. But the catch is the factors of the negative 15 have to add up to give me the linear coefficient. The linear coefficient is a negative 2. So we're trying to figure out what are the factors of a negative 15 to add up to negative 2. Well, we have a 1 and a 15, and really just a 3 and a 5 are the only factors of 15. This 3 and 5 look pretty good, but to add up to get a negative 2, we need a negative 5 for that. So I'm really thinking that this 3 and this negative 5 works. So 3 times negative 5 does give me negative 15. 3 plus negative 5 does give me negative 2. So that does check out. So this comes in and gives me then this x plus 3 times then this x minus 5. That becomes my factorization. Again, if I wanted to use FOIL, if I multiply this back out, these two factors should put back together and give me this x squared minus 2x minus 15. So again, x plus 3 and x minus 5 are the factors. And if you multiply them back out, that should give us the answer. So here, if I want to put that answer there, x plus 3 times then x minus 5. And again, order does not matter there for that. So the second question is, given the binomial x squared minus 36, the first question says, what's the coefficient of the linear term? Remember, the linear term is the x term. So remember, what we have is the quadratic term is x squared. What's missing is the linear term. For the linear term to be missing, its coefficient must have been 0. So we have x squared plus 0x minus 16. So since the linear term was not present, its coefficient had to have been 0. So if we want to factor the x squared minus 36, we have to recognize that this is a difference of squares. So if we have a squared minus b squared, it's going to factor into a minus b times a plus b. It's going to factor into those two binomials. Because what squared gives me x squared would be x squared, and what squared gives me 36 would be 6 squared. So notice how the x is actually the a in the formula, and the 6 is actually the b in the formula. So this just translates over as x minus 6 times x plus 6 as a formula. So that's how that would factor x minus 6 times then this x plus 6. So our next question says we have linear equations. So solve the equation if possible. So right now, I've got this 2x plus 1 times this x minus 1. And it's going to equal x plus 5 times this 2x minus 5. So right now, it doesn't look linear at all. So what we need to do is just kind of start all over and start multiplying everything back out. So we need to multiply the 2x plus 1 times the x minus 1 using FOIL. So the 2x has to go through and the 1 has to go through. So this is going to give me 2x squared minus 2x and then 1x minus 1. And similar over here, I'm going to be doing the same thing, multiplying this x through and this 5 through. So it's going to give me a 2x squared minus 5x and then a plus 10x minus 25. So the next thing we need to do is start simplifying. So if I combine like terms over here, I have 2x squared minus x minus 1. And over here we have 2x squared plus 5x minus 25. So right now it kind of looks quadratic. But when I bring the quadratic terms over, the minus 2x squared and the minus 2x squared, when I bring those over to the same side, the quadratic terms disappear. So it's no longer quadratic. So now I have negative x minus 1 equals 5x minus 25. So this problem now turns into a linear equation. So if it's linear, this side is simplified, this side is simplified, but now I want to get the variable on the same side of the equation. So I pick on the little guy. So I would add an x to both sides of the equation to get the x on the same side of the equation. And again, strategies vary. So -1 is going to equal then this 6x minus this 25. Now I want to get this x by itself. So this minus 25 has got to go away. So to get rid of this, if you will, a negative 25, I want to zero it out with adding a 25 to both sides. So then this turns into a 24 equals to 6x. And then if we divide both sides by 6, we end up with 4. So x would equal 4. So my solution would be 4. So up here in my little braces, I would be putting a 4 in as my answer. So the answer is actually an integer, not a fraction. So even though it kind of looked quadratic, it turned into a linear equation. So linear equation strategies came into play. So the next thing we have is a quadratic equations example. So solve the equation over the complex number system, express exact answers, and use radicals if necessary. So we have this quadratic equation, x squared minus 6x plus 10 is equal to 0. It looks like maybe factoring, but I can't think of any factors of 10 that give me a -6, because all I see is a 1 and a 10 and a 2 and a 5, and they're not going to give me a -6. So it looks like the only way to do this problem is use the quadratic formula. So we have to identify A, B, and C. So A is 1, B is -6, and C was 10. Again, over here, I can write the quadratic formula down. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over this 2a. So when I substitute in, I'm going to be solving for x. The first thing I picked up on is I have to take the opposite of b. So the opposite of -6 is a positive 6 plus or minus the square root of. And then we have to square b. So if we square -6, that's going to give me a 36 minus 10. And then I have to go 4 times 1 is 4 times 10 is 40. So that's going to give me a 40 over then. And then 2 times 1 is just 2. So I have x equals then, looks like I have to do 36 minus 40. Simplify the radical. 6 plus or minus the square root of, looks like a -4 over 2. So x equals 6 plus or minus, and since there's a negative inside the radical, that means an I comes out, and the square root of 4 is a 2, so that turns into a 2i over 2. So my strategy usually is I like to separate this as two separate fractions. So I write this as 6 over 2 plus or minus 2i over 2. And I just simplify each individual fraction. So it's going to turn into a 3 plus or minus I. So our solution would be then those two solutions. So 3 plus or minus 2i becomes our two solutions. So you could separate them as a comma, if you will, as well. So I think the work looks okay there. So you can use those as ways to prepare for your quiz.